Hello and welcome to ATG, the podcast. Today I'm talking to Stephen Webster, who's a senior lecturer in science communication at Imperial College, London. And Stephen was for many years director of the Imperial College Science Communication Unit, which is one of the earliest master's courses on science communication. So very pleased to talk to you, Stephen.
Thank you. I'm happy to be here.
So let's begin a bit with your background. How did you get interested in science for the first time?
Well, I've been wondering about that in preparation for this podcast. I mean, I am a bit of an intertidal organism, so I kind of moved from science to philosophy quite a lot over my career. But at the beginning, yeah, I was interested in science. Maybe it was because I came from a kind of ecclesiastical background. My father was a priest, my grandfather was a priest, so there was a lot of that in the air. And my siblings very much got into literature and the arts. And I was I was very interested in literature, but perhaps I wanted to do something different. So there's that aspect. And then really the simple thing, I had some teachers who I admired. I found myself getting rather interested in some topics like, what is a chemical bond? I remember getting quite obsessed by. And then really kind of I got interested in biology, and then when I got to university I just found physiology, kind of mechanisms by which animals work. That's kind of what grabbed me. So it was one of those things really. I couldn't quite work out quite how it came about, but that's what happened.
But interestingly, after doing life science, you then moved towards philosophy of science.
Yes, so it didn't completely work out. I mean, I did consider for a while doing a PhD. In fact, I was offered a PhD, a funded PhD opportunity. I was studying at Bristol, and I got very interested in microscopy, especially electron microscopy, and I really was fascinated by that. And I was fascinated by kind of what used to in those days to be called whole organism biology. I wasn't at all interested in molecular biology. And in fact, what I was really told was that with my serious lack of interest in molecular biology, this is the 1980s, and my interest in whole organisms, kind of I was going to go extinct because I didn't look like a person who was going to spend a lot of time delving into genetics and chemistry. And meantime, I got very, very interested in evolution. And it may have been I got interested in evolution because it's quite a literary aspect of biology. There's a lot of metaphor. Evolutionary biologists write books a lot. Of course, Darwin himself was no slouch when it came to writing. So for one reason or another, I got interested in evolution, even when I was studying zoology, and that became kind of my main thing, really. And then I discovered that philosophy of science, in those days, a thing called philosophy of biology was getting going. This was the time when philosophers of science were rather giving up on trying to explain the whole of science in 3 sentences. So it's kind of fragmenting. And philosophy of biology was becoming a thing. And most philosophy of biology is about evolution. So I kind of found myself kind of thinking more and more about the nature of evolutionary theory, its structure, how it works, what its kind of evidence base would be, what are the facts of evolution, as well as ethics and politics. And that's really what made me kind of look around. And someone said, "Oh, well, you can go and study philosophy of science, and you can do it at Cambridge, and that's quite a nice place." And as often happens when you're young, yeah, why not? So I had to choose between doing a PhD on the ultrastructure of paramecium, or going to Cambridge and studying philosophy of biology. And I did hum and ha because it was a rare moment in my life really where there wasn't a literal bifurcation. There was a fork in the road: experimental science or philosophy. And I did deliberate, but in the end, the lure of Cambridge and the lure of philosophy was too great, and I went down that route.
Fascinating. And then there was a what must have been another fork because you then spent several years as a secondary school teacher.
Well, I did. I mean, you know how it is when you're young. It's easy to kind of retrospectively look for some kind of order and pattern and try and make sense of it. But when I finished at Cambridge, I really didn't know what to do. And of course, it was a big recession, there was massive unemployment, everyone was very gloomy, just like now. I wasn't sure what to do really. But one thing had happened while I was a teenager, actually. I'd been to see a film. I used to live in Norwich in those days. And I didn't really enjoy Norwich that much for one reason or another. I mean, I don't think it's that great a place to be if you're a teenager. Anyway, I didn't much like it. But I do remember one very important thing, which was I went to a movie. I used to go to a lot of movies, and I went to see a film, and it started off with a what you might have called a B movie. It was really a 10-minute film about a playgroup in Islington called the Islington Play Association. So I was a 17-year-old teenager in Norwich, looking at this film about kids in Islington in London during the summer holidays. And I thought it was amazing. I thought it looked so different. It looked so great. All these kids on trampolines and making kites, and like they were kind of being it was kind of holiday activities, and it really amazed me. And then when my family moved to London, I decided, well, the first thing I'm going to do is make sure that all my holidays I'm going to work with Islington Play Association. It just really grabbed me, and so I did, and that gave me quite a big understanding of kids and what their lives are like in the inner city, and I kind of was drawn to it. I don't know why, but I was, and this meant that when I'd finished my MPhil, and I was thinking about one thing or another, when someone suggested to me school teaching and suggested to me how to do that, and I wrote a few letters. That was it really, and I was kind of got on a place in Chelsea College, and although it was incredibly hard work and were certainly ups and downs, it was quite an important part of my life being a science teacher, especially because in those days, you might say, what's the relationship between, I don't know, doing a Cambridge MPhil in philosophy of science and then teaching biology, in comprehensive schools in the Inner London Education Authority. And it so happened, and I'm sure if it hadn't happened, I would have been in big trouble, but it so happened that the fact I had that philosophy of science degree was a very major element in me always getting interviewed for teaching jobs. And in those days, this is before the national curriculum, there was quite a lot of interest amongst quite a lot of science teachers in Inner London in the nature of science and what science is for. And there'd be a debate about, we're teaching working class kids, why, what's relevant about science? Why would we teach the periodic table to these children? And there's a lot of discussion of concepts like relevance. What is it about science? And it just was the case that quite a few science teachers were very interested in politics. They were very interested in ethics. They were very interested in the idea of the social responsibility of science. And as part of that, very open to philosophical ideas about, science not being certain and science being quite socially constructed. So actually, I found that my understanding of philosophy of science, although I never taught it, if you like, to children, it did help me see, science teaching as kind of intellectually interesting and not just a challenge and not just a good thing to do. But I found it interesting because, in a sense, it kept me learning about science. So it did make sense. It was a jump from doing a master's in philosophy of science to teaching, but it did make sense. And actually, it really kept me in the job. So, for 13 years, I taught in secondary schools. And I think my kind of, if you like, my sort of contextual understanding of science, my desire not simply to see science as a bunch of facts, which you've got to tell everybody, or not simply to think of science as a series of kind of eureka moments of discoveries, seeing science in a different sort of way. It kind of got into my teaching, and it meant I was perhaps more democratic in the classroom. I was kind of interested in what the kids had to say about science, or about what they thought about the universe and what they thought about their bodies, what they thought about health and the environment. And really, philosophy of science teaches us that when it comes to scientific truth, you can't always just rely on trained scientists to deliver what you want. And the sense in which the public have knowledge, which is quite a commonplace now. Back in the 80s, it wasn't really commonplace, but in a well-organized classroom, a well-organized science classroom, you can organize a lot of debate and discussion, and you can get people writing poetry, and you can get science students doing art. It is all possible. Much less possible now because of the national curriculum. Quite soon in my career, the national curriculum came along, and it all became much more set and much more formal, and really much more traditional. So I was lucky. I kind of learnt my science teaching at a time when one could be philosophical and discuss these ideas with kids.
So is this the time when you developed your interest in science communication?
Yes, well, of course, I couldn't stop writing either. I mean, philosophy makes you write, and I'd noticed I'd enjoyed it. And then, I began to write. Actually, writing encyclopedia entries, you'll remember, was one of the first things I did. And I was thinking about this the other day. Writing is a skill, it's a craft, but you've got to have something to write about. But I did get to enjoy, small bits of freelance writing. And I just began to do more and more of it, starting off writing encyclopedia entries, then moving into kind of school textbooks and children's books, then actually getting to write some radio plays for Radio 4 and the World Service. So that just grew. And it was a time when science communication was beginning to be a thing, kind of late 80s, early 1990s. So I began to get a name and began to find that I could be a part-time school teacher and also write. And it worked quite well for quite a long time.
So you coincided pretty much with, as you say, the development of science communication courses, academic courses. I think Imperial was the first. So today there are hundreds of science communication courses. Do you think science is being communicated better today?
Well, I don't know. You see, it's interesting, isn't it? Because when I remember science communication getting going in the 1980s, and the Royal Society saying we've got to take this seriously now, their motivation was the position of science in society. Are we being taken seriously? Are we being funded well enough? Do our political leaders have a good understanding of science? Are we out there? Because I think in the 1980s, we're talking about Margaret Thatcher and the cuts, and was a lot of worry for all institutions about their vulnerability. So, then as now, institutions felt a little under attack with civil service, schools to an extent, the BBC, universities, especially some aspects of universities. And science communication was a bit set up as a kind of PR exercise. Let's make sure people know how great science is and what difference it's making to their lives. So, funding will continue, and so that public support will continue. So I'm sure science communication has moved a long way. I mean, we can talk about how it's changed. But of course, right now we've got extraordinary things going on in the United States of America. We've got an anti-vax believer in charge of a health service in America. British universities are probably in some kind of crisis in terms of their funding model. There are rumours that the amount of science research, the volume of science research now being funded in the United Kingdom is decreasing. So the picture's a bit grim at the moment for science, but you could possibly say it would have been worse if we hadn't been working away in science communication. It could well be that, now more than ever, we need to discuss, how science works in society, how it can work in a good way, how it can work in a healthy way. And we just need to keep working hard on that.
Given your very interesting, quite eclectic background of teaching in a school as well as studying in academia, then going back to academia, you're very well placed to comment on how science is communicated, in the sense that research articles are not known for their intelligibility and accessibility. So is that part of science communication?
Well, and that's really the central point. And really, that's kind of what we looked at on our master's course at Imperial. It would be very easy to say, right, science communication, it's about, I don't know, being persuasive. It's about putting very difficult to understand concepts into simple English, about being clear in your words and clear in. It'd be very interesting to suggest that science communication is a kind of technique for rendering complex material into simple, readily understandable matter. And that's a classic way of describing science communication. And it's not wrong, but it just cannot be the whole of it. And I'll tell you why. To think of science communication like that is to think of it simply as a kind of exercise in transmission. That the role of the science communicator is to take the the difficult scientific paper, or the brilliant scientist, or the eureka moment, and kind of turn it into something which goes down the line to the public. and the public buy it because it's simple and attractive and fun and so forth. But it's simple transmission. There's no debate. There's no dialogue. There's no pushback. There's no contention in it. And I think why I've always found science communication interesting is really that you can fold it into political ideas about democracy, but it's not just a kind of political point. But science communication has to be just as much about listening as about telling. It's not just about persuading people that vaccination is the right thing to do, or that nuclear power is great, or we need to be careful about carbon dioxide. Although all of those things are important, it's also trying to work out what is it that people know already, and what is it that people think about the environment, or energy, or vaccination, or medicines. And the two big things that happened which brought this along, were two things really. One was in the 1980s, there was something, you'll remember, mad cow disease, bovine spongiform encephalopathy. And it was a kind of neurodegenerative malady for cattle. And it turned out, to everyone's amazement, that the cattle had got this disease from sheep. But somehow this neurological disease had crossed from sheep to cattle. So you think, well, how on earth can that happen? Because, cattle are herbivores and so are sheep. And then, of course, we quickly found out that actually this disease which sheep get, called scrapie, some of those sheep were being ground up and turned into food which cattle were eating. So in other words, the disease was crossing into cattle. And it was a disease called scrapie in sheep and mad cow disease in cattle. And it was a nasty disease that had crossed the species barrier. So that's why, a lot of reforms put into the feeding systems for cattle. And also that's why there was a European ban on British beef. And it was a very big thing for quite a large number of years. And in all of that, people began to ask, well, we did eat a lot of hamburgers and we did eat a lot of beef before all this fuss came to light. Are we at risk from mad cow disease? I mean, could the disease cross not only from sheep to cattle, could they cross from cattle to humans? And a kind of, in the story of contemporary science communication, a big moment is when government ministers reassured the public and said, there is no evidence that this disease can cross over. And it's a very interesting example. You can say no evidence till you're blue in the face. And you can be sort of telling the truth, that you probably just haven't found it, or you haven't got the instruments to find it. And actually, this was duly said. And then it turned out that, unfortunately, several hundred people, not thousands, as at one stage been forecast, several hundred young people got this new variant disease, very unpleasant, lethal, sort of accelerated neurodegenerative disease that killed you before you were 25. And so this came about. And after that was a very famous Phillips report, a kind of public inquiry. And they just said this tendency of leaders, especially in terms of technical advice, to reassure the public has to stop. We have to be honest and say, we don't know. We really don't know. And the kind of institutional habit of reassuring people and saying, let's not have any worry about this. So that was a thing where, scientists were saying one thing, politicians were saying another thing. No one was really being very cautious or humble about their knowledge. So this sense in which, above all, at all costs, we as scientists, we as science communicators, have to persuade the public. We know and they don't. That was a kind of key point, really. And after that, the House of Lords produced a report in the year 2000, and they said there's a crisis of trust in science. There's a crisis of trust in science. And what we now have to do is go for dialogue. And so in a way, what was then the phrase public understanding of science, it moved into another phrase, which we use much more now, public engagement. And the idea then became that when it comes to the movement of scientific knowledge through society, you cannot just reckon that the scientists and their knowledge can sort of be in charge of that. You've got to interact with the public or publics, because you've got lots of different groups involved. You've got to work out what their concerns are, what they know already. And that really was what kind of set the pace for subsequent work. That successful science communication, really, you've got to think about your audience. So just as a writer has to think about their reader, it's obvious. So a science communicator has to think about their public too. And it's a fatal mistake simply to think of the public as a bit ignorant, not very knowledgeable, not really knowing very much at all. And what's missing is proper technical knowledge. So it had a name, the deficit model. And the idea would be that science communication made up the deficit. But when you think about it, if you take another example, nuclear power, or take another example, the building of a runway at Heathrow. The people around Heathrow will have lots of different views about this. Some will be thinking, oh, right, well, more jobs. And other people will be thinking, right, air pollution, asthma, it'll split up. And those people who are worried about asthma and air pollution and health, they will become extraordinarily knowledgeable if they want to, because they're motivated, about air pollution. So they can be as knowledgeable about air pollution as any nuclear physicist or as any kind of plastics chemist. And so that's another thing we learned, that actually to do science communication well, you really need to imagine that your listener, your reader, knows a lot or could know a lot. You cannot just assume they don't. And then, of course, science communication changes, because then maybe the job of the science communicator is not so much to persuade the public of this or that, or to get the good news out there, but maybe the job of a science communicator is to kind of work in public, to have a kind of work as partners, and that's been tremendously influential. And that's why what we call outreach quite often with universities, which sounds like kind of sending it out. In a sense, it's kind of reaching out. It's about universities working with people around in local communities on what the research means. And it can get quite radical, because some universities might be so adventurous as to say, well, maybe we need to talk to people around us about what kind of research they want. I mean, you could get into a situation where, well, the public pays for research. Maybe they ought to have a say in what research actually takes place. These are debates now which happen quite frequently, and it's more and more common, for example, in medicine, for teams of medical researchers researching diabetes, for example, or various forms of cancer. It's more and more common for them to say, well, let's find out what patients would like. Would they like to live longer, or would they like the pain associated with this disease to be reduced? There are choices to be made.
This is fascinating. Can you give an example or two of this kind of outreach?
Well, yes. I mean, certainly with where I am, Imperial College. So we've made a big thing of buying up some land in on the A40. It's called Imperial College West, and it's got a very strong program, and it's got quite a lot of facilities where local schools can come in, where young scientists especially go out and produce various forms of science communication. Courses in science, you not only get kind of master's courses like the one I used to run, but it's very common now in postgraduate training to have science communication. It's very common in undergraduate courses for there to be modules in science communication. So there's a sense in which you might say, well, to be a good scientist, or to have a good identity as a scientist, is to have science communication skills. So really, any science institution, whether it's Wellcome or the Linnaean or the Crick Institute or any university, they will have these programs, and they wouldn't describe themselves as simply communicating their research and sending it out there and saying how great we are, although they do that, of course. They'd also say, no, we're trying to engage local communities with what we do. Now, you can criticize it and you can say, how real is it? But that is a major effort at the moment. And it's part, of course, of, if we're going to have universities, and if we're going to have universities in every major town, then, if you like, the townspeople have got to see why that research is valuable. So it kind of, the question you asked me, what makes good science communication, you can see why immediately I see it as partly a political question. It's partly a matter of how knowledge and expertise kind of flows through society and how it benefits everybody.
This is a very useful corrective to some of the thinking in open science, and we can come on to open science a bit more, where people talk about that all's needed for a research article is to add a plain language summary to solve all the problems of it.
Completely. I mean, this is a complete misunderstanding. It's like I said at the beginning, it's so easy to think of science communication as simply a matter of the lay summary or, talking simply and clearly. And that's true. You do, I mean, there might be an argument that you need to talk simply and clearly. Although actually, you might be able to portray something wonderful about science and something very moving and entrancing in language that's very complicated and opaque, and difficult, but still something comes across. But certainly, science communication has to have a sense of interest in the public, interest in how society works to be successful.
Fascinating. Can we talk a bit about your more recent involvement, which is in the whole topic of research culture, which I think is you're involved in something called the Good Science Project. Can you tell us a little bit about this?
Yes, well, that's right. But this has been quite an interesting kind of another phase of my career. So I, in due course, I've spent quite a lot of time running this unit and felt it was time for a change. And the college said to me, would you like to be involved in working on what's called research culture? And by research culture, we simply mean the kind of immediate environment of scientists, what it's like in the lab, but also kind of what it's like, what's the lifestyle like of a scientist? How difficult is it? How secure do you feel? How convivial is it? How collegial is it? The idea is also quite interesting because you might imagine, many people I think would imagine, but when it comes to science and being a successful scientist, it's simply a matter of, choosing a right experiment, working hard, using something called the method of science. You do that and all will work. But actually, any scientist will tell you that science is a very human activity. And it very much depends on relationships, and it very much depends on trust and, a kind of good mentoring, as well as diligence and working hard and taking it all very seriously. And the kind of umbrella term is research culture. And understood like that, you could see that actually some research cultures would be better than others. That's also very easy to see. You can imagine that however interested you are in your science and however bright you are, if in some sense you feel very insecure about whether you're going to get a job at the end or whether you're going to get another grant, or that actually the competitiveness is too great and the pressure to publish is too great, you can imagine that could slightly kind of tell on how much you enjoy your work and how happy you are. And that could tell actually on how successful your science is. One can begin to develop arguments that, good science depends on happy science, if you like. So this has become, something universities are worrying about, because science, no question, has become, it's a hard environment, especially if you're a postdoc. Will you get another postdoc? It's quite hard to get academic work in universities. Maybe 7-8% of PhD students get what we might call, tenured academic work. It's very hard to move from postdoc to a permanent job. So there's a degree of stress. There is a degree of stress, and everybody knows this. And I was asked about this, and I just thought, well, of course, I can't do anything about that. This is maybe it's capitalism, or maybe it's just huge. But one thing for sure, scientists always say there's no time, and we don't get enough chance to think about what we're doing. And one of the things that's interesting about science is there's no question about the reasons people are in science. You asked me, how did you, Stephen, get into science? And I told you what interested me. And I told you also when I was an undergraduate, and I got really interested in microscopy and in protozoa, and thought about doing a PhD. And if I had done a PhD, it would have been because I was really interested. It would have been because I was fascinated. It wouldn't have been because I want to make Cambridge University the best in the world. And it wouldn't have been because I want to, become famous, really. It would have been because there's something here about understanding nature that really, really is important. And I think that's why research culture is a vital thing to consider, because, science depends on its young. Science depends on people going into it. And if they go into it, not in order to make Imperial College the most famous university in the world, they go into science because they love it. There's something they find wonderful and interesting. Of course, it's difficult, and of course, it's repetitive, and there are bad days, and takes tremendous endurance and very hard work. That's all fine. But if somehow, as a young scientist, you think the odds are stacked against you, it's really too difficult, and somehow the atmosphere is poor, and there's just no time to talk about ideas and share things. So I said, I think the most important thing is to really try and make time within an institution, in my case within Imperial, where we can meet and discuss the very many aspects of research culture. So that's really what I started doing, just setting up meetings. At first they were called Friday Forums. I've also organised a couple of conferences, one called the Day of Doubt, one called Prism of Research. And they're really attempts to take this seriously and to say, if there's a problem with research culture to do with how scientists work and the sense in which the environment helps them do good, trusted, democratic science, then it's very important that scientists can talk about that and kind of discuss priorities and learn from each other and maybe talk to people from outside the department. So that was really my thought. And I said, it won't be expensive, but you will need to give me a sandwich budget because we're going to need to meet in person. Probably Fridays are best. I mean, it's hard to get people to come in on Fridays, but in a way it's a good time because you're more relaxed. And what I found was that if you organise something and make it reasonably comfortable and reasonably sort of interesting sounding, people will come. And I mean, the final point about this is that scientists are very busy and under huge pressure, and really need to press on. But they know about talking to each other, and they're very generous with each other. You just need to set things up and slightly kind of down pedal all the talk about being the best in the world, and slightly emphasize, we do our best science when we can work together and listen and take some time when necessary.
I was lucky enough to be invited to the Prism of Research Day and listening to some of the most eminent scientists. And it was, I found it, what I took away was quite shocking, the sort of the tales of intensive weekend working and particularly for medical training. So it was, and that contrasted very much with the young early career researchers who talked about quite idealistic and practical things. There was a. Did you see that kind of contrast?
Yes, and that's why we kind of wanted to have that session where the young scientists talk about what they like about science, what makes a good day, and it's reassuring. I mean, it'd be terrible to think that our young somehow didn't have a genuine interest in discovery. But that was there, in that recent conference, loud and clear. And it's true also, the older salts will talk about how tough it is. I think what can happen a little bit, you see this sometimes in medicine. People say, "Yeah, it was very difficult for me too. That's how it is," But I think it's kind of got a little bit more pointed. I think the research culture has become a little bit more perilous. I think the difficulties which were always there. I mean, it's always been competitive science. It's always been people trying to be first, and it's always been hard. We know that. That's fine. The question is it kind of getting too much? For example, cost of living crisis, the difficulty of studying in London, the difficulty of getting work, the difficulty of operating in a grant system where actually money is short now. Science has become much more expensive for a lot more scientists than there were 40 years ago. So it's tight. And I think maybe we're at a point where actually that tightness, that difficulty is becoming really quite pressing. So what would have been, a tough environment and quite hard work and not for the faint-hearted, but it's great. You just have to persevere, and then you will be rewarded. I think the kind of slight sense now is you can work as hard as you like, and you can be as tough as you like, but it's going to be luck and survival more than anything to do with you. So the idea that your success as a scientist might in the end have not much to do with you, because basically the odds are stacked against you so comprehensively. I think that's what's focusing minds right now. And because there's a lot to get right, because there are, as you mentioned, there's all this tremendous work going on with these great people going into science. It's all there, and we just need to nurture that spirit and cherish these people who are going into the field.
So do you think it's possible to identify a good research culture?
Well, I think it's. I think that I'm sure it's not true. There's just one research culture. I'm sure it varies, but I mean, a lot of surveys have been done about this, and we know several things. So one is that although scientists are prepared to work hard and quickly, they know they also need to loll around and think. They know they need time. They see science as perhaps not quite an intellectual activity, but an activity which requires thought and time. So that's one thing. So you need to have a culture where there's time. And the second thing is that all scientists, they do love discovery. So philosophers might have wondered quite what discovery is, and is it simply kind of reading nature in a way of we read a book, or is it more to do with the person kind of projecting ideas and seeking out what they already know and looking for confirmation of? But nevertheless, the idea of finding out new things and understanding how something works is terribly, terribly important. And scientists will say that delights me when I really understand something. So that really comes down to autonomy. And if you can't follow your nose, if you can't suddenly think, you know what, I want to spend time thinking about this now. That does sound like a very germane aspect of being a scientist, and you could call that autonomy. So I think another aspect of research culture, or research culture, which people would fake, would be one where you can follow your nose a bit. You've got a bit of creativity. Your imagination has importance, and we know that science can be very punishing to the imagination because there's so much to do in terms of instrumentation, facts, stuff already learnt. The imagination, your creativity, your autonomy are hard to look after, but I think they're crucial. So that would be the second thing. And then I think the third thing really is that, and it's linked, is collegiality. The idea that you're working with like-minded people, the idea that others in your laboratory have got your back, the idea that in your discipline you're all working together. It's not an elite sport. It's more of a cooperative enterprise. This is an idea which people have now. Of course, it's often not like that. Laboratories do compete. There's so many stories of people wanting to be first. Survival can be quite a pressing image in one's mind. But I think those are the three things would sort of collegiality, a degree of autonomy, and having time.
I'm sure you've been following the discussion about open science, and much of the collegiality and community idea of that you describe seems to be picked up in open science. If you look at things like publish, review, curate, the idea of open peer review and collective peer review, that seems to be going in the direction you described for good research culture.
Yes, I mean that is extraordinarily interesting because you could the way science kind of works, generally speaking, is you hunt for a grant. You develop an idea, and it's your idea or it's your team's idea, and then you hunt for a grant, and in that grant are some costs for publication, perhaps. But essentially, it's kind of preordained, and that does lead to kind of competition. This group gets the grant, that group didn't get the grant. It's kind of winners and losers. What you don't have really, or what one could try to set up is, well, what sort of research do we want? We've got these resources, we've got these universities, we've got these teams. What research does society need? Now, I'm not saying that, we need some kind of planned economy like in kind of communist Russia. This is the science we need, we're going to do it this way. But you could imagine where science becomes much more deliberative, where somehow it's not kind of teams in silos chasing their own fantastical ideas, but where somehow it's more sort of worked out together. And open science can take people down that road. You can sort of make links between teams, kind of farm out problems, make collaboration more easy because it's noted, it's marked, it's seen as important. So in other words, normally in science, it's the end point. Success comes right at the very end. What goes on beforehand, who cares would be the traditional point, and who cares can hide a multitude of sins. The open science thing is it's all open and noted from the beginning, and although there might be a slightly sort of managerial, slightly totalitarian aspect about everything has to be seen, it doesn't have to be like that. It can be just a way of saying daily life in science is as important as the eureka moment.
We've barely touched on, you mentioned that you've written things, but I've looked at the amazing range. You mentioned radio plays, but several books, including children's books and as you say, most recently a biography of Darwin. So which of these have you enjoyed most?
Well, I think I must admit, I was thinking about this, because it was writing that kind of got me into science communication. It was just something I enjoyed doing. And I kind of enjoyed working with editors, people like you. I like that thing of sort of writing something which you knew somebody would read, even if it wasn't read much by the public. I always liked that. So actually, with writing, I mean, perhaps it's my fault, but I've never been very disciplined. I mean, I did enjoy writing for children. I found it incredibly hard. I mean, certainly the hardest thing I ever did was write a couple of books for the Children's Museum in Halifax, Eureka. And these books were for 6-year-olds. And I found that remarkably difficult. Then I wrote some radio plays, and that was different and difficult, but I enjoyed that. But actually, the most recent thing I've done, as I was describing to you, is write a biography of Darwin. It's just gone into a second edition. And in this second edition, I've been trying to, partly, in relation to what you've just been talking with me about research culture, what's the relevance of Darwin to today's scientists? I found I couldn't get that out of my mind. So the first edition was very much simply his biographical detail. So I think, if you had to say what have you enjoyed most, I'd have to say the most recent thing, and the most recent thing is this new edition about Darwin. It's also kind of latest, because I suppose to some extent writing is rather hard, and when you've finished the project, it kind of fades into the distance. But yeah, right now I'm admiring Darwin and loving writing about him.
And you mentioned already that Darwin is a classic example of this crossover between science and the arts. And one thing that characterises your entire career has been to pull those two together in a way that's, I think, that's very unusual. So, do you think there's more that science can learn from the arts and vice versa?
Yes, I do. I mean, I mentioned to you that I was going to do, when I was thinking of doing a PhD, the first PhD I was thinking of doing was on microscopy of paramecium, these little protozoa. But in the end, the PhD I did eventually was on relations between science and art. And what I did was interview a lot of scientists and especially a lot of artists to work out, why is it that you get science-art collaborations, and why is it that it's a thing, and they've been funded quite often. Wellcome Trust used to fund a lot. And there's an artist in residence in my Good Science project. And I think what's interested me was not that artists can illustrate science, which of course they can do. So, you can find a very good way of communicating science can be through art. And that can be very, very effective. But I think I was interested in whether, the way an artist works and the way a scientist works, there's some there's things they can learn from each other. So a very simple one would be, it's not true that scientists deal with nature and materials and instruments and the hard work of reality, whereas artists simply deal with themselves. Artists have also got to finish their work. They've got to exhibit it. They've got to deal with paint. It's rather like making a table. The table has got to stand upright. And so there are rules about art. So that was interesting to me, that the kind of, in a sense, they're both experimental. Scientists experiment, artists experiment. The second thing I found very interesting was kind of an ethical thing. Artists are like society's antennae. They think about society, they think about where stuff is going, and so there's no real reason why artists shouldn't find themselves thinking about gene editing or the trend or vaccination. These are things which artists can think about. So not always, but sometimes artists have been very effective in sort of trying to see what questions are at play. If you're trying to vaccinate a population and you're doing it through the public health service and through the state, Are there some ethical questions there? What are the difficulties we need to get right? And artists can be just very, very good at asking those questions. And then the final thing, which I think is interesting, is that we think of scientists as researchers, and trying to find out stuff, and having a process of research. Maybe doing some reading first, buying some equipment, talking to people, and actually artists themselves. They also research. They don't just simply classically stand in front of an easel and paint or write a novel. They've got to think very, very hard about reality. A novelist, no novel is going to be successful if the reader doesn't think, that's real. That's how I feel about myself, or I know somebody like that, or no, this, the United Kingdom is like that. So there's an interesting sense in which, although artists, in a sense, are kind of making things from nothing, there's an interesting sense in which they're describing reality. There's so many good examples, but for example, if you think about 19th century art, before about 1860, um, art was extremely figurative, and a tree would look exactly like a tree as presented to us. And then, when, roughly speaking, when Cézanne came along, it began to fragment, and kind of Cézanne's view about colour and about landscape and about light and colour. You've got a strong sense, well, yes, that is a landscape, that is Mont Saint Victoire, but there's no question this is not a photograph. And of course, what had happened in the interim was that photography had been invented. So there was a sense in which there was no point really doing art, which is just a kind of straight representation. And then, in short order, following Cézanne, one thinks in the next 30 years, Picasso coming along and Cubism. And when Picasso talked about Cubism, these extraordinary paintings of, somebody walking down a stair, or a jazz clarinetist, and you can hardly see because it's so fragmented. But then you realise what Picasso is saying. This is a jazz clarinetist over 20 minutes, and I've been walking around him, kind of thinking about what he looks like. So those cubists, and Picasso in particular, they'd say this is more real. This is more real than those 1860 type figurative artists who just painted one perspective. We've got all these perspectives. So I think that's a final point about art and science. It's a kind of philosophical point. We tend to think of science as discoveries and great innovations and tools and cures and solutions, but it's really much more than that. It's a sort of an amazing probing of nature. It's trying to understand something very difficult to see. It's always partial. It's never complete. It's a picture, really. It's never a whole picture. It's not like a photograph of 1850 of a mountain. It's just not like that. It's changing all the time. And I think that is a sign of its connection with art, because of course art is exactly the same. Artists are trying to describe something real. It might be something real about them, the artist, but very often it's about relationships, or nature, or animals, or children, or love. It's kind of they're trying to tell the truth, and that again makes artists different from, say, an accountant or a media executive. Again, you think arts are different, and I think one can think about science too. That science is so useful and so penetrative and so so successful in its interventions. One forgets it's a sort of intellectual exercise of wonder. But exactly the same can be said about art. Art is, 99% of it will be graphics. 99% of art will be used in straightforward illustration. But actually, art is important because it kind of probes and researches and finds something new. So it's rather like the debate between religion and science. You can have a similar conversation, and in a way, again, you come up with the same things. Both scientists and religious people, when they do the thing properly, and they're not just interested in final truths, their exercises in wonder and exploration. So that's why I got interested in science and art. And I found actually that at Imperial, whenever I've run a few arts projects with the Good Science Project. We've just put up a lovely tapestry in the library made by scientists, and we're just doing a wonderful animation made by scientists. And it's very, very remarkable that as soon as you say at Imperial, well, look, I'm gonna run an arts project, and you just have to come along, and there will be sandwiches. The room is full.
It sounds fascinating. Well, we haven't got time to talk about more, but I very much look forward to the new edition of your perspective on Darwin in the revised in the updated edition. So so I look forward to that coming out, and to whatever else you might come up with. So thank you very much for your time, Stephen. It's great to talk to you.
It was a pleasure. Thank you for inviting me.